Today's topic is the particle theory of matter. So let's look at the different points of the particle theory. Point number one, all matter is made up of extremely tiny particles. So every single bit of piece of material that you see that actually takes up any space is made up of all these little tiny particles. Each pure substance has its own kind of particle, different from the particles of other pure substances. So if you look at something that is consistent throughout, that is considered a pure substance, and we're going to look at the term pure substance, and we'll explain it in a little more detail. Each one of these pure substances will all have their own composition, okay, and they're all going to be different from one another. Point number three, particles attract each other. So the particles are held together by some kind of a force of attraction. Point number four, particles are always moving. So even though you look at something that is considered a solid, and we know that all the particles to the solid, okay, are all close together. So we're looking at a particle, let's say we're going to consider this our ice cube, okay, and we're going to make reference to water and ice throughout this chapter. And so we're looking at the particles that make up ice, and we know that water is H2O, water, okay, pure substance. It's exactly H, two H's, one O throughout the entire substance of this ice cube. So what happens is these particles in a solid are constantly vibrating. Okay, and as we're going to see ultimately, that once we actually add heat to this particle here, this ice cube, the particles are going to vibrate even quicker, and eventually they're going to kind of break apart, forming the liquid. But we'll worry about that as we move on with this chapter. And the last point, particles at a high temperature move faster on average than particles at a lower temperature. So going back to this ice cube, the particles of this ice cube vibrate very minuscule compared to the particles of its gas counterpart. So when we melt this ice cube into the liquid, the particles in the liquid vibrate a lot quicker than the particles in the solid. And when we evaporate that liquid into the gas, the particles will continue to vibrate even quicker. So, particle theory of matter is one example of a scientific model. A scientific model helps scientists to picture processes in nature that cannot simply or directly be seen. We cannot really see these little particles. Okay, so we use this scientific model to kind of demonstrate what is actually occurring, to kind of come up with some kind of an explanation of why does this solid, okay, melt into this liquid, why does this liquid evaporate into this gas and then go backwards. Okay, so we're trying to explain that all the particles here in the solid are all close together. We continue to add heat, the particles start to vibrate, they move apart from one another, they break apart from one another, but now we go from an actual shape to particles that actually take the shape of its container. And that's the same with both liquids and gases. So we're going to talk about the different phases or states of matter in just a second. Matter is anything that has a mass and volume. Mass is a measure of the quantity of matter of an object. So we're going to measure mass in terms of kilograms, grams, milligrams. Okay, and it's going to be, this term here is going to be very useful when we look at density later on in future chapters. Okay, we have volume. Volume is a measure of how big an object is or how much space a fluid takes space. So we're looking at really the amount of space that's being taken with our object. So if we've got, let's say, a brick, okay, the volume of the brick is pretty much everything that's taking this shape, everything within it. We've got a container with some kind of a liquid. What is the amount of this liquid that we have in this container? What is the volume? Okay, that we're taking up. You know, very common units for volume. We've got liters, we've got milliliters. We're going to be looking at, for some solid shapes, centimeters cubed. And finally here, matter can be classified as either a solid, a liquid, or a gas. And we've already just kind of briefly talked about these ones. And we're going to look at now, how do we move from a solid to a liquid to a gas?